Okay, thanks, Grant. So I basically was just going to wanted to introduce this library that I use quite a lot when I'm doing my C# programming. It's OneOf library, which, as it says there, gives you union types in C#. I mostly do F#, and we get union types for free in F#. And they're really cool, actually. I never really used them. I never used them before I did any F#. I like them, but occasionally I have to do C#, and so this is the library that I go to when I want to get this kind of functionality. So, first thing, what is a union type? I guess, in a way, it expresses an OR relationship. It's kind of like a type that can be an A or a B or a C or a D. It's a limited set of types. So in a way, it's kind of like an enum. So an enum, has an overriding type name, and you can only have one of these three cases, except that an enum is backed by an int. And if you could attach rich types to an enum, this is kind of what a union type is. So if you were to deal with the success case, it's an int. The error case is a string. Okay. I googled what languages have them. I know F# has them. Turns out Rust has them, and they look just like that made-up definition pretty much when you define them in Rust. You get them in TypeScript, where this number or string, it defines a union. Here's what they look like in F#. Obviously, they're the nicest looking of the lot. And then in this OneOf library, obviously they're not in the language, so it's slightly more clunky, but you can see here it reads quite nicely. It's a generic type, and you get placeholders for all the different cases you want to support. So it's quite nice. I think you can get up to 10 placeholders. And I think by conventional I tend to have the success case as the first one, and all the rest would be my kind of failure cases, So this is clearly a one-off. Either I get a user type, or I get a dictionary of int or string back. Okay. So that's what it is. Why would you want to use it? 9 times out of 10, it's to represent the return value, a result from a function which is kind of polymorphic by design, but which you can't really express very nicely in C# as it is. So, as an example, you've done your nice library, you've got this create user function that purports to create you a user if you give it a string, but of course, you've been around the block once or twice, it doesn't always create you a user, so you've got this, occasionally gives you a null, and if you're a good citizen, you return a user, user. And this isn't too bad, at least it's quite readable. You know that if you try and dereference that thing, it could be null, and the compiler might help you with that. But it doesn't tell you anything about why it might be null. So then what you do, you can sort of mess around with maybe tuple types, or you create your own class hierarchy to return, or whatever. Or you reach for the thing that you see in all the other libraries, which is like, I tell you what, if I can't create it, I'll throw you an exception. And if you give me garbage, I'll give you another exception. And I really don't like this. I mean, you can have your own argument about whether exception-based control flow is a good thing or a bad thing or whatever, but that notwithstanding, this is really not type-safe. I don't like, this is not a type-safe function in the sense that the compiler can't really help me to interact with this function in a robust way. So I mean, if I'm in the nullable context, yeah, I'll give you a squiggly. I'll say you might, if you try and dereference that user type, but it's only a warning. I can still compile my app, I can still run my app, I can still blow up at runtime. I know you can make it an error, but not out the box, And also, it doesn't tell you, it doesn't care if you catch any of those exceptions. You could just let them go up the stack, and so it doesn't really help you fall into the pit of success, if you like, when dealing with this function. Now, if we were to redefine this in terms of a union type, now, okay, it's more verbose. But on the plus side, it's more verbose, right? So I can read that, and I can see what I'm going to get back. I'm going to get back either a user, something that represents this name has been taken, something that represents I've got some invalid input. I don't have to really know anything about those objects even at this stage. I kind of know, I have more sense of the intent of this method, this function. And this is now, number one, I don't have to catch those exceptions. So I would argue those exceptions are not exceptional. Invalid input in this context isn't really exceptional. So I've managed that within my return type now, so my exceptions can be saved for things that are truly exceptional. So I'm not having to deal with that, and this is now kind of much more type safe. The compiler will help me with this, as I'll show you in a minute. And if you wanted to, you could, if you think this is too verbose, you could inherit from the base class and do something like this, which is more what you do more what I do in F#. So you create a result type that wraps those options, but the end result is the same. It's still more type safe, which I quite like. So how do I interact with that OneOf thing? There's only about half a dozen methods on it, and the two you would use most would be, there's a switch method, which is semantically equivalent to a switch statement in the sense that it executes a block of code for every case. And there's a match method, which is kind of like the switch expression. In other words, it returns a value. So you've kind of got one that takes an action, one that takes a func. That's the two main ones. There are a couple of other things you can do, but these are the two main things you would do. So let's have I wrote a Noddy app. So you would download it. Oh, you can't read that. That says install package OneOf. And then I've done the. It's not supposed to be there. So here's my Noddy app. So a tiny little console app, but you can see here, so here's my function that creates this user. So just a couple of things I'd like to point out here. One is, I'm just switching on some basic cases here, null, empty string, and so on and so forth. One really nice thing is I'm not having to create one of these big generic types every time. I'm just creating the type that I care about. Let me just actually, I'll just increase that a bit. So I'm only creating the types that I care about. So I'm just saying, if it's null, it's an invalid import. If it's Steve, it's never already taken. And it wraps it all up into the generic type for me with some operator overloading, which is really nice. These are my sort of Noddy types that I've defined down here for this particular function. I quite like doing this. So you create a type that is named for the case that you want it to represent. It makes total sense. You don't have to use primitives everywhere. And then I've got my consuming function up here, which you can just see as a console app that loops forever taking input. And there's my switch statement. So I've got my three cases in this instance, and I'm writing out to the console, so I'm using switch. So a couple of things I'd like to point out as well. You might be thinking, I could do all of this with like records and switch expressions and all that, and you'd be right. But one of the things I like about this is that if you do switch statements or switch expressions, you can default out like half your cases, and the compiler's quite happy with that. So if you were going to do this, you say, I'm only caring about the happy path, default out all the rest. A switch expression would be quite happy with that, and a switch statement would be quite happy with that. Whereas this thing, you can see straight away I get a red squiggly, and it says you haven't handled one of these cases, because it actually treats this, which looks like a default, treats this as case number 2 of 3, and says you haven't dealt with number 3. And why I think that's quite nice is if you, for example, decide you get halfway through your development and you want to add a new thing, you instantly get a compile time error. So everywhere in your code base where you've used this type, it's going to now not compile because you haven't explicitly handled this new case, which I think is really, really nice, because if you do it with a switch, it'll just compile. And runtime errors lurk in that kind of oversight, So I think that's really, really good. One thing I wanted to show as well, that you don't always have to define your own types, because there is a little namespace under this in types where you can see there's about a dozen pre-built types that represent some of the common union use cases, like results, options, where something could be maybe, or something or nothing. So you don't always have to sort of roll your own. I think it's got a really nice use case in APIs, web APIs actually, because I've only just started doing these, but I find that a lot of the time people are interested in the happy path, and all the exceptions just percolate up the stack and get thrown back as a 500 server error sort of thing. Whereas with this, you can manage them so trivially, map your returns to specific HTTP results that why wouldn't you do it? Is sort of my feeling. Gosh, I've got like a minute left.
Wow.
I could actually run my Noddy program, because
I'm expecting a big thing.
Well, I mean, I think you can imagine what it's going to do.
I'm interested why you might be called Stove.
No, that was just my holy crap, this is like really. So if I choose a good name, obviously I just get that created,
Of course.
There's another good name that works fine. Empty name, I get a nice rich result, which just says you can't have an empty name. If I do something that's got like invalid characters in it, again, I get a nice rich descriptive result, but it's a type safe rich result. And of course, if I do, oops.
So poor old Mr. O'Rourke's out.
Mr. what?
O'Rourke.
I don't know what that's a reference to.
He's got with a high.
Oh yeah, no, actually that's a good point. Yeah, because I think this is just the. Yeah, I think this is just. Yeah, there you go. So poor old Mr. O'Rourke. But again, this is just a Noddy example, isn't it? Yeah. So there you go. That's it. Try it. Download it. Hope you like it. Thanks very much.
Nice.
Oh, look at that. That was bang on.
3 seconds, Nick.
3 seconds over.
3
Yeah.
seconds. Right. Any questions?
Any questions?
What's the
Yes.
license like?
Do you know something? Yeah, I was thinking the same thing. I thought, God, I didn't check the license. I think it's completely open source. It's a
Which
really,
open there?
it's a really nice little library because it's not dependent on anything, and I think it's got about 20 million downloads. So it's not like some, you know, it's relatively well used. So yeah, but I don't actually know what the license is. Yeah, have a look.
I'll look it up.
Does anyone do Rust and Type? I mean, there must be people who do Rust and TypeScript. Do you use these all the time in Rust and Type? Because I just use them all the time in F#. They're so handy.
A bit.
Yeah.
Yeah, one of my favourite things about TypeScript is the type system.
Yeah.
So having this available in C#
Yeah.
is lovely, and I've had scenarios as well, like you said, throwing exceptions for non-exceptional cases, where those exceptions bubble up, but where they bubble up to, they also handle specific exceptions. So what can happen is a bit of a mismatch if you don't, you catch in a general section, general exception, but you can miss that, and that can just create chaos.
Well, this is it, and I say you're leaving yourself open to runtime problems, which, you know, again, using F#, you kind of, it steers you away from that kind of problem, which is quite nice. So I mean, there are other libraries that do this kind of stuff. This is just the one that I found. It's succinct enough and self-contained enough that I just use it all the time. So.
Curious, Microsoft saw fit to include it in TypeScript, but not in.
Yeah, it's a funny one, isn't it? But it is a funny implementation in TypeScript. I think it's not quite as rich as it is in F#. I think I've never used the TypeScript one, but looking at it, I thought.
It's Microsoft way.
Yeah.
But you've got to
fit. There's functionalities in the C#, it's not in VB.NET, and in VB.NET it's not in C#.
Well,
Well, there's a different debate. Let's not open that one.
but at one point they were at the same level, weren't they? And they still had this.
Yeah, I mean, it just feel like, to be honest, the way C# has been going for the last few iterations, it's just been taking stuff from F# left, right, and centre. And I would imagine this kind of thing would make it in because you know, simply for like result types and stuff like that, for exception-free kind of programming, it just makes a lot of sense. Keep the exceptions where they should be for dealing with exceptional stuff, and then have clear results for everything else is the way I would go about it.
My question was about the efficiency of it, because throwing exceptions all the time is inefficient. Granted, if you get to that point of trying to tweak your application, then you're in a good place anyway. Is this more efficient than doing that? And is it a real compile time error, or is that something that you've got to configure in the IDE to recognise that?
Oh no, that's because that type, you know, is going to be one of those 3 cases. So the compiler just by default knows that if you haven't had, because all you're doing is giving in an action or a func for each of those 3 cases, or 4 cases, or 5 cases. So actually, the whole type is pretty much auto-generated. You can see it on NuGet. He swapped it out. I think it was originally hand-coded, and he was like, "Hey, I can just generate all this because it's boilerplate with overridden methods for T0, T1, T2, T3." So he's gone up to T10, but you can generate T20 if you want to. So yeah, it's all burnt into that type. So the compiler instantly knows you haven't dealt with case 3. So it's really good like that.
It's the OneOf switch, isn't it? That's got that logic rather than the type itself.
Yes, sorry, it's the switch method which expects the 3 funcs or actions. Yeah, exactly. There's another method called try-pick. So basically, like try-pick T0 would say, give me a T0 if you can, otherwise give me everything else. And that has certain use cases. So perhaps that would be the thing where you say, look, I really only care about the success case, and everything else can be damned. But in general, I prefer to stick to the switch and match methods because they are exhaustive in that regard. So. Any others?
MIT license, by the way.
Is that good?
Yeah, good.
Right. Okay, good.
Oh, it's got 2 vulnerabilities though.
Oh, really?
Oh no.
Well, that's interesting because it doesn't have any dependencies as far as I know.
Well,
Yeah,
it's
but
got
in itself. So version
Yeah.
3.1, version 3, and version 2. I'm not gonna. No, I'm not going to try and interpret the actual vulnerability.
Yeah, I wonder what it does.
What do you mean this is your job?
I mean, not live.
You've shattered the dream.
Yeah, that's it.
Go away.
I mean, that's
and
quite
go
weird,
away
actually.
A few days for that.
One of them allows remote attackers to execute arbitrary code on vulnerable installations of Foxit Reader. So that's a pretty niche vulnerability. That one.
Yeah.
So what, that's for people writing plugins for Foxit Reader, is it?
Exactly. So there's an example of accepting risk.
How many people are using Foxit?
Sod all.
Anyway, sorry.
Got it?
Semantic PDF.
Any more questions on topic?
No worries.
Lovely.
Thank you very much. Cheers.
Thank you very much, Steve. Thank you.